Hi guys. So today we're going to be talking about the Pythagorean theorem and its converse. Okay, so before we get started with our example, let's just review the Pythagorean theorem again. Okay, so Pythagorean theorem, in a right triangle, the sum of the squares of the measure of the legs equals the square of the measure of the hypotenuse. In other words, a squared plus b squared equals c squared. Which leg is A and which leg is B does not matter. However, C has to be the hypotenuse. And again, hypotenuse is the side that is across from the right angle. Okay, and it's also going to be the longest side of your triangle. So with that in mind, we're going to get started with example 1. Okay. So California's NASA Dryden is located at about 117 degrees longitude and 34 degrees latitude. NASA Ames, also in California, is located at about 122 degrees longitude and 37 degrees latitude. Use the line of longitude and latitude to find the degree distance to the nearest tenth between NASA Dryden and NASA Ames. Okay, so NASA Dryden here is 11734. Okay, NASA Ames is 12237. Right, and so basically, what we know then is from here to here, right, from 122 to 117 is a distance of 5. Right? From 37 to 34 is a distance of 3. And so here it forms a right angle. And so this would be my unknown. Okay, and so what we can do is 3 square plus 5 square equals our unknown distance squared. Okay, 3 square is 9, 5 square is 25. 9 plus 25 is 34. Okay, and then when we square root both sides, get c by itself. Square root of 34 is the distance. However, that's not very helpful in helping us realize how far that really is. And so this is approximately 5.8. Okay. And so this means is the degree distance between them, so that way I don't have to write out the whole word, between them is about 5.8 is about 5.8 degrees. There you go. Okay. Ooh, little blurry. Okay, so why don't you try CYP1 and then once you're done, come check your answer. Okay, so the degree distance is about 17.1 degrees. If you got that right, you can move on to your next example. If not, here is your explanation. Okay, so first I found the difference between the degrees latitude. So 36 and 30, it's a difference of 6. Okay. 95 and 79, it's a difference of 16. So 6 squared plus 16 squared equals c squared. 6 squared is 36, 16 squared is 256. Add them together, you get 292. Right? We're going to get rid of this square by square rooting both sides, and square root of 292 is approximately 17.1, and that gives you your distance. Right? Okay, moving on to example 2. Okay? So here we want to find x. Okay? X, however, is one of our legs. Okay? This is our hypotenuse, 14, right, because it's across from the 90-degree angle. Ooh, blurry. So this has to be C. Whichever one is A or B does not matter. Okay? So I'm just going to write x squared plus 7 squared equals 14 squared. 7 squared is 49. Okay? And 14 squared is 196. Right? Then I'm going to subtract the 49 over. So 196 minus 49 is 147. Right? Then I'm going to get rid of the square by square rooting. So x equals the square root of 147. This simplifies to 7 square root of 3, which is approximately 12.1. And there you go. So why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten that x is approximately 10.8. If you got that right, you can move on to example 3. If not, here is your explanation. Okay, so x here, which I'm looking for, is also a leg, so it's either A or B. Okay, here's my right angle, so across from it is the hypotenuse. So 16.2 is my hypotenuse, so that is why 16.2 is in the position of C. Okay? So then it's x squared plus 12.1 squared equals 16.2 squared. 12.1 squared is 146.41. 16.2 squared is 262.44. Then I'm going to get rid of the 146.41 by subtracting it on both sides. That gives me 116.03. And then last, I'm going to get rid of the square by doing the opposite, which is square rooting, and that gives me approximately 10.8. Okay, we're now going to move on to example 3. Okay? So here, it says to verify that a triangle is a right triangle. Right? So before, when we did our coordinate geometry and our coordinate proof, what happened is we just found the slope of this and the slope of this, and if they were perpendicular, they had to have formed a right triangle, right? But here, since we're practicing Pythagorean theorem, we're going to be using the Pythagorean theorem, okay? So what's going to happen is we're going to find the distances of each of these sides, okay? So let's start with PQ. Okay. So distance formula equals, okay, PQ equals the square root of -3 minus 3 squared plus 6 minus 2 squared. -3 minus 3 is -6. 6 minus 2 is 4. -6 squared is 36, and 4 squared is 16. This gives me the square root of 52. Okay. And I'm just going to leave it as that for now. Okay. Then I'm going to find PR. Okay. So square root of 3 minus 5 squared plus 2 minus 5 squared. 3 minus 5 squared is -2 squared. 2 minus 5 squared is -3 squared. -2 squared is 4. -3 squared is 9. And 4 plus 9 is 13. Okay. And then my last side here is QR. Square root. So -3 minus 5 squared plus 6 minus 5 squared. Okay. -3 minus 5 is -8, and 6 minus 5 is 1. -8 squared is 64, 1 squared is 1, and 64 plus 1 is 65. Okay, so now we've got each of the sides. And so this is the biggest. So if this was a right triangle, this would be the hypotenuse, and here would be the right angle. So now we're just going to see is PQ squared plus PR squared equal to QR squared. Okay? So let's plug in what we know. So PQ is square root of 52. So square root of 52 squared plus PR squared. So PR is square root of 13 squared equals QR is square root of 65. So square root of 65 squared. Okay? So 52, the square root and the square cancel to be 52. The square root and square cancel, this will be 13, and the square root and square cancel to be 65. 52 plus 13 is 65. So does 65 equal 65? Yes, it does. And because the Pythagorean theorem works for it, it is a right triangle. So triangle PQR is a right triangle. And there you go. Okay. Would it have been faster if we just did the whole perpendicular thing? Yes, it is. But here we're just practicing Pythagorean theorem, and this is how it works when we're doing it on a coordinate plane. Okay. So why don't you try CYP3 on your own, and then once you're done, come check the answer. Okay, you should have gotten that triangle ABC is not a right triangle. So using the distance formula, you should have found that AB is square root of 10, BC is square root of 5, and AC is square root of 13. Okay. Square root of 13 being the biggest, if this was a right triangle, this would be the hypotenuse. So that's why it's in the position of c squared. Okay. So using the Pythagorean theorem, square root of 10 squared plus square root of 5 squared equals square root of 13 squared. So this becomes 10, this becomes 5, and this becomes 13. 10 plus 5 is 15, but since 15 does not equal 13, the Pythagorean theorem didn't work for this, and so that's why it's not a right triangle. Okay, and we can use the same idea here to test whether or not something is a right triangle. Okay, so what you need to make sure is you need to know which side is the biggest, because that's going to be in the position of C. Which one's A, which one's B, that doesn't quite matter. Okay, so here in my triple, 8, 15, and 16, 16 is the biggest, so that has to be in the position of C. Okay, so we're seeing, does 8 square plus 15 square, does it equal 16 squared? Okay, so again, the biggest number has to be in the position of C because the hypotenuse is the longest side of a triangle. Okay, so 8 squared is 64. 15 squared is 225. And 16 squared is 256. Okay. 64 plus 225 gives you 289. Does 289 equal 256? No, it does not. And since the Pythagorean theorem didn't work for this, this is not a right triangle. Okay, they're not the measures of a right triangle, not the sides of a right triangle. Okay. This next one is square root of 3 over 5, square root of 6 over 5, and 3 over 5. Okay. So square root of 3 is about 1 point something because it's less than square root of 4, which is 2. Square root of 6 is about 2 point something because it's in between square root of 4, which is 2, and square root of 9, which is 3. Okay. So that means this 3/5 is my longest side. So that means that's going to be in the position of C. Okay. So let's test it out. So square root of 3 over 5 squared plus square root of 6 over 5 squared, does it equal 3/5 squared? Okay, so this square root of 3 squared becomes 3, 5 squared is 25, square root of 6 squared is 6, 5 squared is 25, 3 squared is 9, 5 squared is 25, 3 over 25 plus 6 over 25 means 9 over 25. Does 9 over 25 equal 9 over 25? Yes, it does. So this does form a right triangle. However, it is not a Pythagorean triple because these aren't whole numbers. So it is a right triangle, but they do not form a Pythagorean triple. There you go. Okay. So why don't you try CYP 4A and 4B, and then once you're done, come check the answer. Okay, for 4A, you should have gotten that it is a right triangle and it's a Pythagorean triple because the Pythagorean theorem works for it, it ends up being true, and because they're all whole numbers, it makes it a Pythagorean triple. Okay. For 4b, you should have gotten that it is a right triangle also. However, they do not form a Pythagorean triple because these are not whole numbers. Okay? And so, again, the square root of 2 squared, the square cancels. That's why it's 2 over 49, 3 over 49, and 5 over 49. And there you go. That's it for today. Have a great rest of the day. Bye, guys.